This is just part 2 of relative velocity, where we just have one detailed example. And we've got an airplane flying due south of YVR Airport with an airspeed of 105 meters per second. It is a windy day on the west coast with the wind blowing west at 18.5 meters per second. What is the resulting ground speed and direction of the airplane? So, right away that tells you you've got to find a velocity and an angle, so speed and a direction. What do we know? We know airspeed, so the velocity of the plane to the air is 105 meters per second. We know the air to the ground, because that's wind is compared to the ground, which is at rest, 18.5 meters per second. We should add our directions. This is going south, and the wind is going west. And we are looking for the ground speed, so plane to the ground is that. And we're also, so we're going to look for the angle as well as the magnitude. So to do that, we will have to set up our equation. VPG is velocity. Now it's P plus, and G is last. Our other air script is A, so we just put that in there. VPA, VAG. Well, we have both of those. Plug them in. 105 meters per second south plus 18.5 meters per second west. Again, we can't do this directly because they are not in a straight line. So let's draw our vector that is going south and then west. So we've got VAG over here and V plane air over here and V plane G. And this is our angle. So what are we going to come up with? So first, the ground speed. So we want to figure out VPG, which if we're pretty confident with Pythagorean theorem, we know will be VP, the square root of VPA squared plus VAG squared, which square root of 105 meters per second squared plus 18.5 meters per second all squared, and then square rooted, and we get from our calculator 106.62 meters per second, and that will be to 3 sig figs. We also want to figure out our angle before we say our final answer. So our angle, theta, we always want to use what we're given, so it's better to use tan, though you could use sine or cosine, which would be VAG over VPA, which, plug in our numbers, VAG is 18.5 meters per second over 105 meters per second equals an angle of 9.992 degrees. So we're not really that far off of our original direction, but in terms of flying a plane, that makes a big difference. So what is our final answer for, well, let's see, our ground speed. So VPG will be 107 meters per second, and then our angle will be 9.99 degrees. Go back up to our diagram, and we are west of south is how I solve that. So those are our two final answers, our direction and ground speed. So always when you're solving relative velocity questions, always look for this pattern where you've got the first letters lined up, the last letters lined up as well. And then your third subscript is in between. So make sure you always have that pattern. If you have a problem that you have a subscript that is V, for example, PG, but you have to relate it, you can use this relationship. That if you switch the subscripts around, that they are negative, then the vector just becomes negative. So that's something that you might have to use on problems, and we can talk about that more in class. This is a useful list of keywords. Take a look at those. That makes your life a little bit easier when you're not used to setting up your subscripts. It gives you most common things, because relative velocity questions will be planes, boats. That's probably about it. Planes and boats are most common things this year, so we'll do a lot of planes and boats. And as always, the end of Unit 3 physics is certainly still awesome.